Now that we have our beams and columns done, we can start working on the smaller members of our model. So one of the members that I see is this piece of wood on top of the beams. So we're going to add that in. Because we don't have any actual measurements, we're going to have to do our best to guess what the member size is again. I'm just going to guess that the member size is a nominal 2x8, which would be 7.25 inches by 1.5 inches. After I draw my rectangle on the right view, I'm going to use snapping to grab the midpoint and line it up with the midpoint of the column. And then use the extrude curve command and pull this piece of wood all the way across my beam. We'll take a look at this photo again and see if the sizing looks about right, and it looks about okay, so I'm just going to copy this piece of wood to all of the other beams. Now we can take a look at the rafters. When we zoom into the rafters, we see that they're actually notched, so they're not really sitting exactly on top of the beams, but they're actually cut so they have a little indent that lets them sit snugly in. And when we make our rafters, we're actually going to include that cut. So to start, we need to get our dimensions of our rafters, and it's really fuzzy in these drawings, but we'll do our best to make an educated guess. I'm going to guess that the rafters are nominal 2x10, which would be 9.25 inches by 1.5 inches. Now, because the rafters are at an angle, it might actually be easier for us to construct the rafter just somewhere on the ground and then rotate it into place. So I'm just going to draw here in perspective on the C-plane. And then I'm going to take my rafter curve and extrude it to some arbitrary length up. Now we can try to rotate this piece. So in perspective view, I'm going to grab the piece, and using the gumball, I'm going to try to rotate it. Let's say 45 degrees. Maybe that's what it looks like. And when we do this rotation, we see that 45 degrees isn't really accurate if we look at our right view of our short section. So we might need to rotate this piece using commands rather than a gumball. To start, I'm going to measure the angle between the horizontal ground and the slope of the roof. So I'm going to use the angle command for that. I'm going to start by drawing just a tiny line, and I'm going to use the bottom piece of the line as my reference point for the angle command. So the angle command prompts me to draw a line, so I'm going to draw my first line starting from the bottom of that tiny line I just drew, going horizontal, holding shift to snap. And then I'm going to draw a second line starting from the same place, and have the second line follow the slope of the roof. Then the command will spit out an angle between the two lines for me, and I'll use that angle to rotate my rafter accordingly. Now let's just double check how exactly the rafter sits on top of the beam. So if we zoom into this image that we found, we can see that the bottom of the rafter lines up with the bottom of that piece of wood that sits on top of the beam. So we're going to use our move command, grab the bottom of the rafter and snap it to the bottom of that piece of wood. So now we're going to have to cut that piece of the rafter out, the piece that intersects the piece of wood as well as the beam. So to do that, we're going to trace the outline of this piece of wood and the beam. Remember, project is still on here. So we're going to trace the outline, and then we're going to use the command cell last, and that will select what we just drew. And we're going to take our selection and we're going to extrude it so we have this kind of trimming gutter here. Then I'm going to use the Boolean trim command like we did before. And after that, I'm going to hide the gutter, and I'm going to hide the beam as well, so I'm just left with the rafter. And we can see that there's like this little piece that's kind of not attached, and we can click it and delete it. And now we can see that our rafter is formed properly. So we can type show to show everything that we just hid, and it looks good. So now we're going to do the same for the other beams. So I'm going to take my trimming gutter and I'm going to copy it in right view. Remember, project mode is still on here, to the other beams. We can see here that the snapping isn't going to work for this last beam, so we have to copy it from a different reference point. So now we can see that the rafter is a little bit too short, so we can use the extrude surface command to pull the surface of the edge of the rafter further out. And then we can merge the coplanar surfaces again, and now we have a rafter that's longer than the appropriate length. So now we can move this trimming gutter in right view again to where it's supposed to go, snapping correctly. And now we can use Boolean split on that one. And then I've forgotten to move the rafter to a different layer, so I'm going to make a new layer. And then if I want to save this sort of gutter piece that I'm using to form my rafters, I can create a new sublayer and stick it under that, change the layers of the objects. Now if I hide the beams and columns, we can see that this rafter is looking real nice. And we can also take a look in our right view and make sure that everything's checking out. So let's go ahead and show everything again in our layers panel. And if we want to trim our rafters, we can do them in the same way that we did the beams before. We can go ahead and use planar surf to make surfaces out of these curves that we've created as our bounding box, and we can use the Boolean split command to use these planes as trimming planes. Now that we have our girder trimmed to size, we can copy paste it to every single spot it needs to go in. So if we take a look at this long section here, we can see that there are actually tons of rafters that we need to copy paste. So let's get the distance between them all. So using the distance command, we're going to just grab the distance between two rafters, and it looks like 1.5 feet, which seems pretty reasonable. So instead of copying and pasting this rafter multiple times, we're going to use a different set of commands. So when we want to create arrays of different things, we can use the array sets of commands. And I'm going to use array linear because I'm creating a linear array of the same element repeating multiple times. So array linear will just prompt me for what it wants. So it's going to ask for the number I want. I'm just going to guess maybe 10. And then it's going to ask for a reference point. So I'm going to make sure project is still on, and I'm going to type 1.5 feet. And then hold shift to snap to 90 degrees and click, and it will form all of my rafters. And here we can take a look in perspective to see that all of the rafters appear there. And this last one's kind of hanging off, so we can just hide that away by changing it to the sublayer that we created. Don't forget to save your work. So now it's time to work on the bracing, or the diagonal elements of this building. Now because the plans and sections aren't very clear, we're going to have to cross-reference those with images that we find online. So this image is pretty good. It shows a lot of the connections, and this image as well will be very helpful to us. So we'll cross-reference these and make sure everything lines up when we draw them with our plans and sections. So my first step would be to kind of figure out where everything goes. And to do this, I'm going to create a temporary layer and just sort of sketch in Rhino where I think that these elements will go. So in the short section, we can kind of see this V shape appearing. So I'm going to draw that, and then I'm going to go into perspective as well as the plan view and line up this V with the column lines. So now when we move around in perspective, we can see that we've correctly drawn this V. Now because of the way that our columns are laid out, the V underneath this beam is only going to appear here. So now we can rotate our view 90 degrees and take a look at the long section to see which elements we'll be drawing, and we can see the same sort of V pattern appearing here. In the long section it's a little bit less clear, but we can start slow and just make sure that we're drawing what actually exists. So based on the previous image as well as this long section, we can sort of understand that these brace pieces run from column to column. Vertically, they go up kind of 2 beam spaces. We can also see by looking at this image that there's this connection point in the middle, so we have to make sure that we account for that. We can start by drawing this one diagonal bracing that's running parallel to the long section, and then because these bracings in the long section are symmetric across every single column, we can draw the bracing that's going the other way as well. Now when we're looking at what we just drew in perspective, we can see that these bracings don't really line up with anything, so we have to adjust for that by looking at both the plan and the short section, and we can scoot this V to sit underneath the beam and on the column. Now because these bracings are very much repeated for the most part along every single column, I know that after I draw the members I can just copy them over, and because all of the base bracings are the same, the bracings will fit between every single column perfectly. Now again, because these pieces are getting smaller and smaller, our dimensioning will be less and less accurate, so we're really going to have to guess. Based on the images, it looks like this is about a 2x4 piece of lumber, which is very standard piece. I'm going to create a new layer for bracing. I'm just going to draw out a rectangle that's 3.5 inches by 1.5 inches, and this process is going to be very similar to the way we did the rafters, by extruding and then rotating to match the angle that we desire. And then in perspective, plans, and sections, we can line up this bracing such that it matches and fits in exactly where we want it to be. Now we want to make sure that these bracings are perfectly centered. We can see here in plan that this bracing isn't actually exactly where it's supposed to be. So what we're going to do is we're going to use the move command, and with snapping turned on, grab the middle of our bracing piece and then find a point where we can snap to the middle of. In this case, I'm going to snap to the middle of my column. Now, because this piece is slanted, when we use the gumball, we can see that the gumball doesn't actually line up with the piece. So if we wanted to slide the piece back and forth along its own axis, this wouldn't be possible. In order to fix this, we're going to change what the gumball is a reference to. So if we type gumball alignment, we can actually align the gumball to the object itself rather than the default C-plane. So here we can see that the gumball is now changed, and we can slide it back and forth, and we can slide it such that it fits in between our two columns. Now we can change the gumball back to C-plane and slide the bracing down to where it matches on the short section. And then I'm just going to extrude this bracing out. Now we could either make this bracing an individual piece, or because it looks like this element of bracing is linear throughout multiple bays, we can actually chop it all up all at the same time. And to do this, we're going to use the Boolean split command just like we've been doing before by selecting multiple columns. And just be aware that when we're splitting with objects as opposed to planes, that the Boolean split splits along the planes that comprise the objects. So we actually have to hide the objects that we've used to split and then delete the insides of the object that we were splitting. And then just type show to bring everything back. And if you're selecting multiple objects and you make a mistake, you can always use Control to deselect the object that you clicked by mistake. We can now copy the bracings over to the other columns where it needs to be. We can see that only this bracing would be copied over because there are no other columns that the other pieces of bracing would attach to. Now, in order to complete this V shape in the short section, we can take a copy of this bracing and just rotate it around so that it's a mirror angle of the initial bracing that we had. Then all we have to do is line the bracing up by both snapping in the long section and then using the gumball to move it in the short section. And once it's lined up, we can use the Boolean trim command like we did before. Then once we have this piece of bracing, we can take it and using a common reference point, copy it to the other columns where the bracing exists in the building. We can now start working with braces in the long section by taking a bracing in the short section and in top or perspective view, rotating it 90 degrees. Then in a similar process, we need to match the angle of this piece of bracing. So in order to do that, we can take the bracing and move it so that one end of the bracing is lined up with where the bracing would be if it were angled. And then we can use the rotate command to rotate the bracing such that it matches the drawings. Once we do this, we can again use the move command to snap the bracing to the center of the column and then just line everything up again. Once our piece of bracing is at the correct angle, we can again use Boolean trim and copy paste this piece of bracing wherever applicable. Now, these bracings are symmetric across these columns, so we can take these and swing them over to the other side as well. And we can do that using the mirror command. So we're going to select the objects that we want to mirror, and then we're going to go into plan view and draw a mirror plane. And this will make all of the objects that we've selected symmetric across that line that we're drawing. And then we can go ahead and Boolean trim the excess away. Now there's one detail where these two bracings cross, and we can see in photos that there isn't actually a piece in the middle, but instead there are these metal plates that kind of connect everything together. So we're going to model that very simply. Now to do this, we're just going to draw boxes where the metal plates are. And so we're going to turn project off and use the box command. Now because boxes typically snap to the C plane, we're actually going to use the 3-point setting in the box command in order to make our box aligned with our own points. Now when we want to manipulate things in the settings line in Rhino, we don't actually have to click them. We can just start typing the name of the setting and enter, and it will automatically open the setting that we type. So if I type 3 into the command line and press enter, the 3-point setting will be applied. And then I can just use the 3-point setting on the box command to draw out my box. And I'm going to assume that the plate is 1/8 inch thick. Now when I check back on the image, it looks like my 1/8 inch plate might be a little thin, so I can extrude surface if I need to. So in order to get rid of the center piece between these two bracings, I'm going to use Boolean split, but I'm going to use both objects as the cutting objects and both objects as the objects being cut. And then I can just delete the centers. Now I can take this plate and using snapping, move it from the plate's center to the bracing column center. And then I can copy it from center to center and then create a copy of this plate. Move the edge of the plate to the edge of the bracing, and then going into front view, rotate the plate so that it lines up with the bracing. Then all I have to do is take that plate that I just rotated and center it by moving it, snapping the center of the plate, snapping to the center of the column, and then copy this again to the other piece of bracing on the bottom right. Then I'm going to join all of these plates together by using the command Boolean union, and this will create one solid object from multiple objects that are intersecting. Again, we're going to use merge coplanar surfaces here and then trim away the excess bracing that overlaps with this new set of welded plates that we've just created. You could then also try to make the bolts, but I'm not going to bother. Now all we have to do is double check all of the images and the plans and sections and make sure that we're not missing any pieces. So it seems that I forgot 1 or 2 pieces here, so I'm just going to take the existing pieces, and because all of these columns are sort of regular and have the same set of bracings, I can take it and copy it over. And I can also see that I forgot to trim these pieces correctly, so I'm going to go ahead and do that. Now that I have all my geometry set up, I'm going to trim everything down to this initial bounding box that I set up at the very beginning. So I'm just going to create planes on all 4 sides, and then I'm going to Boolean trim everything against all 4 of those planes and trim away all the excess that's sticking out. And we're left with something that looks a little bit like this. Now we can begin to model the roof. So underneath the shingles are these long wooden pieces called battens. So first, in order to model them, I'm going to make sure that I turn project on, and I'm going to create a new layer called battens. Then I'm going to go into right view, and I'm going to draw rectangles that correspond to the sections of these battens. So I'm going to use the rectangle tool and then type 3 to make it a 3-point rectangle so I can line it up with the angle that the rafters are on. And based on the images, it looks like these smaller pieces are maybe 2 inches by 2 inches, and the bigger ones are 2 inches by 4 inches nominally. So I've just created a copy of the 2 inch by 2 inch rectangle, and because I know that the 2 inch by 4 inch rectangle is twice the length, I'm going to click this little red square in the gumball tool, and this is like a scale tool. So when I click it, I give a scale factor, and in this case it'll be 2 because it's twice as long in the red axis. And when I type 2 and hit enter, it will scale my selection to 2 times its length. So I'm just going to draw them out and then change the gumball such that it lines up with the object, and then do my best guess to see what the spacing looks like. So according to these images, it looks like there are 6 sets of small and then big battens. So I'm going to use the array linear command, and I'm going to type, and I want 6 objects, and then I'm going to select the reference point and then make the array. And here, I don't really know the spacing between them, so I'm just making my best guess as to what they would be, such that all 6 pieces kind of equally take up the spacing between these columns. Then I'll use the cell last command to select the array that I just created, and then holding shift, add the first 2 rectangles to my selection, and then I'm going to use the copy tool, and by selecting a repeatable frame of reference like the top of these columns, I'm going to copy the battens across all the spans as well as above and below. Then all I have to do is delete the rectangles that don't fall on the rafters. Then I can select all the battens by right clicking the batten layer and selecting all the objects within the layer, and then using the extrude command, extrude all of them in the long section view to make them stretch across the length of the module that I'm working in. Now, when we look at the actual images of this pavilion, we can see that not all the battens go all the way across. So within this image, I'm going to take a look at where my section is and find that on the ground, and then kind of move my way up the column to sort of figure out where the roof kind of lines up. And based on this, I can see that the thicker battens end somewhere halfway in between this rightmost span between these two columns. And I can see that the thick battens look like they also continue after about a few spaces in the upper span between the two columns. So I'm going to go ahead and make a plane that I'm going to use to cut these, and use Boolean split to split the battens that I think should be split. And you can kind of see, based on my selection as well as the short plan, which battens I believe do not extend all the way across and which do. Then once they're split, all I have to do is go back and delete the ones that don't exist in real life. And after doing this, the only thing left is the little bit of shingles that I think are in the top right. Now, I'm not going to model every single shingle individually, but I will create a representation of where the shingles will be in the model. And to do that, I'll just create a simple box where I think the shingles will be. So with my snapping, I'm going to turn project off, and then I'm going to create a box using 3-point of where I think the shingles appear, and I believe the shingles are probably about an inch thick, so I'm just going to type 1 to give it that thickness. And this is what we end up with for our roofing. And if you want, you can always just draw shingles in on top of this box. So now we're going to model the ground. To start, I'm going to create a new layer called ground and make sure I stick it under 3D. I'm going to create the slab that sits on top of the footing. To do this, I'm going to make a box, and I'm going to go into top view and start by tracing the outline of our working area in top view. And then I'm going to come into our front view and pull the box down the depth of this slab piece. Then I'm going to draw our footings much in the same way we did our beams, and this is all very approximate because we don't have any image reference of what's under the ground. So we're just going to rely on what our plans and sections show. So we're just going to go ahead and trace these footings and extrude them in the section that runs across. And once we have our slab and footing, we're going to select everything and Boolean union everything together so it's one big piece. Now, because I drew these footings a little bit too far, I'm going to unhide my temporary layer that has the surfaces and just use those to Boolean trim my footings. Now, just like the shingles, we can see in this image that there are actually brick patterns here. I'm not going to model every single brick, but if you wanted to, you could always just draw the outlines of the bricks on the slab. So our 3D modeling is basically done. But if we want to take this 3D model and make it a 2D drawing, there are a few things that we can do. So first, we can turn off everything that we don't need, so the pictures and all of our other markings. And then I'll create a new layer called 2D. And then I'm going to click the drop down again, go to set views, and then isometric, and then choose any one of these options. And this will make the view parallel. And parallel views are what allow us to convert our 3D models into orthographic drawings in Rhino. So once you find the view that you like, you can also orbit it around if you find a view that you prefer. We're going to use the command make 2D. Once we run the command make 2D, we're going to select our object that we want to draw, and now we're going to take a look at these settings. So first of all, make sure that your view is set to parallel, and in your projection, make sure that it's set to view. Then under object properties, I'm going to select that the properties are going to be derived from their input layers, and then I'm going to uncheck every single box. You can play around with these settings if you like. Sometimes some settings are better for certain scenarios, but for now, I'm just going to turn everything off. Now, when we run make 2D, we can see that the output gets put on the C plane. So now we're going to switch over to top view, and we're going to take a look at what we got. So it looks pretty good, but when we zoom in, we can kind of see that there are some errors in certain places. So at this step, what we would do is we would clean up all of these sort of errors that we find here. And then after cleaning up the errors, we can create layers that represent our different line weights and thicknesses and start transferring the different lines to their corresponding line thicknesses. And once we have all of our thicknesses set, all we have to do is use the print command, and we can print our 3D models as 2D representations on paper.